type number 2. What is the type number 2? The equation of the type, the equation of the type f dash of x dx divided by dy and plus p f of x and this is equal to what? Q, where p and q are functions of y, where p and q both are functions of y and can be reduced to the linear form, okay, by substituting, or you can say by putting f of x equal to what? V. Okay. Now differentiate this. If you're differentiating this, you will get f dash of x dx upon dy and this is equal to dv by dy. Here I am differentiating with respect to y. Okay. Now the equation 1 means what? The given equation reduced to. Therefore the given equation reduced to. Therefore the given differential equation reduced to what? dv by dy and plus p v equal to what? Q, which is a linear form, which is in linear form, which is a linear, or you can say which is a linear differential equation, which is a linear differential equation. Okay, so you know very well how to find the linear solution of linear differential equation. Yes or no? Which is the linear differential equation. Okay, therefore the solution of this differential equation is given by, therefore the general solution of this linear differential equation is given by what is that? V e raised to integration of p dy equal to big integration q e raised to integration of p dy plus c, where c is the integrating constant. So after integration we will resubstitute. Okay, and then after integration we shall resubstitute all values. We shall resubstitute all values. Okay, so that will be the required solution. So that will be the required general solution of given differential equation. Okay, so this is the procedure how to solve. What type 2 says that? The type 2 says that if the given differential equation is of the form f dash x dx by dy plus p f of x equal to q, where p and q both are the functions of y, and then this differential equation reduced to the linear form by putting f of x equal to b. Now differentiate this f of x with respect to y, so you will get f dash of x into dx by dy equal to dv by dy. Okay, now substitute the value of this in the given differential equation. So your given differential equation will be reduced to the linear form, that is what dv by dy plus pv equal to q, which is a linear. Now you know very well how to find the solution of linear differential equation. So this is the formula for solution of linear differential equation. Now after finding the solution of linear differential equation, we resubstitute all the values, so that will be the your required general solution of the given differential equation of the type 2. Now let us do the problem based on this. Example number 1. Solve the differential equation. Solve the differential equation y into sine x dx by dy minus cos x equal to 2 times of y cube cos square x. Okay, we write solution. So before finding the solution, we must copy the given differential equation. So we write the given differential equation. Given differential equation, what is that? Y into sine x dx by dy minus cos x equal to 2 times of y cube cos square x. Okay, now see here. So before finding the solution, we first observe the given differential equation. So see here, in the given differential equation, we must want right hand side. Right hand side must be what? Functions of y only. तो यहाँ पे देखिए, just observe here, there is a functions of x also. Okay, so we want to remove the functions of x. We want only functions of y. So for this we divide by cos square. Yes, cos square x. Okay, but now here we want the function. If I putting this, so we must want the function and their derivative over here, but here y is unnecessary, so we also divide by y. So by combining both the terms, both the sides, we divide by y into cos square x on both sides. Getting? So dividing on both sides by y cos square x. Okay, we get what? Y sin x divided by what? Y cos x, cos square. Okay, cos square x, and dx by dy minus cos x by y cos square x, and this equal to what? 2y cube cos square x and divide by what? Divide by y into cos square x. Okay, chलिए let us simplify. This y cancel, and we write here sin. देखो here on the denominator we will have 2 cos. Okay, 2 times of cos. So this become what? 1 upon cos is what? Sec. 1 upon cos we can write sec x, and sin upon cos, that is what? Into tan x. Okay, and dx by dy, and minus 1 cos and 1 cos will cancel to become 1 upon cos x. Okay, so we write here 1 upon cos is what? Sec. 1 upon cos is what? Sec x divided by y, and this equal to, here 1 y cancel, so this become here y square 2y square, and this cos square x, this cos square x will cancel. Okay, getting? Yes or no? So yes, your given differential equation is of the type this. Now okay, if you comparing this, we will find here p of x is this one, sec x, and p of x is what? Your p of x must be functions of y. So this is the p of x, 1 upon y is the p of y, and q of y is 2y square. Okay, so we putting here, put sec x equal to what? V. Okay, this sec x equal to V. Now differentiate this. If you differentiating, you will get sec x into tan x dx by dy equal to dv by dy. Getting? I am differentiating this with respect to y. So derivative of sec is what? Sec x into tan x, and derivative of v, that is dv by dy. Now substituting this in here. Substitute this in here. This is the what? Equation number, say equation number star. So therefore the equation number star reduced to equation number star reduced to what? Just substitute all the values. This become what? dv by dy, and minus sec x is what? V by y, and this is equal to 2y square. Getting? Okay, which is a linear differential equation, which is this, which is a linear differential equation, which is a linear differential equation. Now you know very well how to find the solution of linear differential equation. Therefore now comparing this with standard form of linear differential equation, that is what? dv by dy minus db by dy minus what? P of y, p is the function of y. Okay, and v equal to q of y. We get p of y. P of y is what? What is the p of y? P of y is negative of y, that is minus 1 upon y, and q of y, q is the function of y, q of y is what? 2y square, this one. Okay, now our job is to find the integrating factor. Therefore integrating factor, bolo. Yes,
सर सब p of y इक्वल टू माइनस 1 अपॉन y लिखते हो सर, लेकिन ये भी तो सर माइनस p of y है ना,
प्लस ले लो आप, ठीक है? यस, गेटिंग और नॉट? हाँ, तो e रेज टू इंटीग्रेशन ऑफ p of y and dy, just find out the integration. E raised to integration of p of y is negative of 1 upon y and dy, and this is equal to e raised to integration of 1 upon y is log of y. Okay, negative as it is, log of y. So this can be written as e raised to log of 1 upon y. Negative sign goes on power. So this can be written as what? 1 upon y only. Okay, 1 upon y. Therefore the general solution is given by therefore the general solution is given by, what is the general solution? General solution is given by, that is v e raised to integration of p of y dy equal to big integration q of y into e raised to integration of p of y dy into dy plus c, where c is the integrating constant. Now substitute all the values over here. So let us move to the next page. So we write here v as it is, e raised to integration of p of y. We found how much? We found value of this, the value of this we found here, 1 upon y. So 1 upon y, and this is equal to integration and q of y. Q of y is how much? Q of y, that is what? 2 times of y square. 2 times of y square. E raised to integration of p of y dy is how much? How much? 1 upon y and dy and plus c. Okay, where c is the integrating constant. Just simplify this. So you will get 2 I'm taking outside. So 1 y cancel, this become only y here. Okay, and dy plus c. Okay, now just integrate this. So after integration you will get 2 integration of y is what? Y square by 2 and plus c, where c is the integrating constant, and this 2 and this 2 will cancel. So you will get therefore v into 1 upon y, and this is equal to what? Y square plus c. Y square plus c. Okay, now resubstitute all the values. Resubstitute all the values. Therefore by resubstituting we get v is what? Your v is sec x. Your v is what? Sec x, and 1 upon y. 1 upon y is as it is. 1 upon y is as it is, and this is equal to what? Y square and plus c. Now if I divide, if I multiply by y, then what happen here? So this become sec x, and this is equal to, if you multiply y, so y cancel, this become y cube plus c times of y. Okay, and take a common. You can take a common or don't take. And which is the required general solution of the given differential equation? Which is a required general solution of given differential equation? Okay, I hope you understood this. You understood? Yes or no?
सर एक बार रिपीट कर दो.
हाँ,
एक बार रिपीट कर दो ना वही, मतलब कि ऊपर से रिपीट कर दो ना.
अच्छा ऊपर से.
हाँ
ठीक है, जब रिपीट ही करना तो ऊपर और नीचे से क्या फर्क पड़ता है? So let us see. This is your problem. Your problem is given. Okay, so first of all what have to do? We have to just copy the problem. Okay, now we have to observe whether the given differential equation is of the standard type or not. If not, then what have to do? We must make this as a standard type. Okay. So see here, we are observing here. This is the right hand side must be functions of y, but it is not. So for that, we dividing by y into cos square x on both sides. So make this in standard form. Okay. So this is the standard form of the type 2. Okay. So for this, but this is the not in linear form. Okay. So we must reduce the given differential equation in linear form. So for this is the functions of x. Okay. So we putting here functions of x, that is sec x equal to v. Now differentiating this with respect to y because it is of the type 2. Okay. So differentiating with respect to y, so you will get sec x into tan x dx by dy equal to dv by dy. Okay. Now resubstitute these values in equation number star. So your equation number star reduced to the linear form, that is what, dv by dy minus v by y equal to 2y square, which is a linear form. Okay. Now you know very well how to find the solution in linear form. So we comparing the given differential equation. So we comparing, given differential equation means what? This differential equation to the linear form. This is the standard type of the linear form. Okay. So if you comparing, so you will get this p equal to what? Negative of 1 upon y, q equal to right hand side, that is 2y square. Okay. Find integrating factor e raised to integration of p of y dy. So integrating, you will get the integrating factor like this, 1 upon y. Okay. Now therefore the general solution is given by this is the formula for general solution. Now substitute all the values over here and integrate them. If you integrating, so that is what, v into 1 upon y, that is integrating factor. Integration of 2, this is the what, q of y. So q of y is 2y square, and this is the integrating factor, and dy plus c. Now integrating, the final solution is this. But after this finding solution, we must resubstitute. So we resubstituting. So v is what? Instead of v, we putting here sec x into 1 upon y as it is, and y square plus c. And just cross multiply, you will get sec x equal to yq plus cy as a required general solution. I hope you understood now. Example number 2, छोटा सा प्रॉब्लम है और बहुत ही इंपॉर्टेंट है, ये आपके एग्जाम में मैं पूछ सकता हूँ. Solve the differential equation, that is what, dx upon dy, and this is equal to e raised to y minus x into e raised to y minus e raised to x. Okay, this is a very important problem, and number of times I have asked these questions. Okay, so please solve this problem at your home. This is the simple exercise for you. Okay.